All right, we are on to the next. So, very last section here, 3.4, volume of capacity of spheres, cones, and pyramids. So, couple formulas in this section that you should take note of. The very first one is the volume of a sphere is 4/3 times pi times the radius has to be cubed. So when I calculate this, one of the things that I will do is I will make sure I cube my radius by multiplying it by itself 3 times. You may have a button on your calculator that allows you to do exponents to the power of 3. Once I have that value, then I multiply it by pi, then I times by 4, and then I divide by 3. Okay. Other things to note, we do know from our last section that 1,000 cubic centimeters is equal to 1 liter. So a liter of milk, think about a liter of milk, is about 1,000. So you've got about a 10 centimeter by 10 centimeter by 10 centimeter, but milk cartons aren't really quite like that. So kind of that idea though. All right, they're a little taller and more narrow. The other thing that I will just mention there is that 1 meter we know to be equal to 100 centimeters. However, we would have, if we have a cube that is 1 centimeter by 100 centimeters by 100 centimeters by 100 centimeters, when we multiply to get the volume of all of that, that is actually going to be 1 million centimeters cubed. So take note that if things are in the millions of centimeters cubed, we can actually change that easily to meters cubed. Okay? Joy of working at home. I don't know if my volume is picking up my garbage truck. It's garbage day. All right, so moving on, I wanted to do an example very much like I have been. Now, this isn't going to show up that great on your camera, or it might show up okay in the images that you have scanned, or maybe the booklet that you have, but here they're trying to show that there is a sphere inside of another sphere, right? So if we think about like the core of the earth and the sphere that's around it, which is the earth, or we think about an avocado pit and a perfectly rounded avocado, that's kind of what this is supposed to be representing. So if the question says a sphere with a radius of 46 centimeters is centered inside a sphere with a radius of 76. So obviously this is the bigger radius, so that's the bigger circle, and then the smaller circle has a radius of 46 centimeters. So we're going to calculate both and then just calculate the difference, so subtracting them to figure out the volume of the space between the two spheres. So that's the first part. So if I calculate my larger spheres first, that's going to be 4 times 4/3 times pi times my radius cubed. And that was 76 cubed. So like I was saying, make sure you cube 76 times pi times 4 divided by 3. Or if you had done 4 divided by 3, you would have got like 1.33 repeating. Make sure you just have lots of 3's when you go to times it by pi. And then 76 cubed, depending on if you have, you can multiply 76 times itself 3 times. And you should be getting, I think it's like 1,838,778.4. So a very large number there. Now we're going to go ahead and do this smaller sphere. Again, same formula, so I won't rewrite the formula. And then we're going to go 4/3 times pi. Now the radius is 46. Do that calculation. We've got 407,720.1. Now subtract these two from each other. So I'll just do a subtraction sign there. Calculate that, and I'm going to get 1,431,058.3 centimeters cubed. Okay, if you guys like the little commas to help you out there, you can. It's not really a Canadian thing to do. What is the capacity? Remember, like we said, 1 liter is equal to 1,000 centimeters cubed. So let's go ahead and just divide that value, the 1,431,058.3 divided by 1,000, and we will get 1,431, and I might round because it would be 0.058. I might just round that up to 0.1 liters. There's your two answers. All right, moving into our next section. Again, couple formulas to record from your booklets. When we have any kind of pyramid, it's going to be 1/3 of the base times the height. So in this case, if I happen to have the base is just a rectangle or a square, length times width times my height. Okay. In some cases, if it gives you the slant height is great when you're calculating area. However, in volume, we do want that perpendicular height, the height that goes directly down the center of the pyramid. So you may have to calculate that using the Pythagoras theorem, and it's like the reverse, where you're subtracting hypotenuse, or taking the hypotenuse squared, subtract the leg squared. Okay, then I did a question I was going to go over with you. I looked for a more complicated one, which happened to have this one here with a rectangular prism with a pyramid prism on top of it. So remember, with volume, it's just the capacity within or inside, so you can go ahead and calculate the volume separately and then just add them together. Perfect. So we are going to do the pyramid section. So that's 1/3 times my base is 22 by 20. So this length by this length. And then my height is going to be the height. Now, it says the height to the peak is 15 feet. That would be from the bottom all the way to here is 15. Now, we know that the rectangular portion is 9. So I would go 9 taken away from 15, or 15 take away 9. It's going to equal 6. So I'm going to do 6 for my height. Do a little calculation there, and I've got 880, and that would be in feet. Then I want to also do the rectangular box, so my volume is length times width times height, so 20 times 22 times 9, and I get 3,960. So it's just a matter of subtracting this, or adding them together. (4,840 feet cubed). I'll just make note, like number 5, it just wants you to take, like, there's a rectangular prism with the same base value and a pyramid with the same base value. The idea is to recognize that when I have a pyramid, it is a third of the size of a rectangle. Okay, moving on. Just going to talk a little bit about, I mentioned this, you would have to use your Pythagoras theorem in some cases to find the actual height. So something like number 6 here, if I'm given my slant height but I actually need my height, then I can go ahead and use Pythagoras theorem. Now this dashed line only goes to the center, which is half of 35. So I am going to have a leg that is only 17.5. So over to the side, I'm just going to use my Pythagoras theorem. 25 squared is my hypotenuse. Take away the 17.5, which is a leg, will equal my height, or the other leg, right? Squared. Now I go ahead and I calculate those. I've got 625. This one works out to be a decimal. 306.25. Subtract those, I get 318.75. And then we're going to square root that, which is 17.9. So now I've got my height. Now I can use my height in the formula for volume. So my volume is 1/3 times the 35 length times width times the height. Altogether, I have 7,290.2. This is in millimeters, and that's a cubed volume. Good. Some more information here. When we have a circle or a cone is going to be, because the bottom is a circle, you use pi r squared, which is the base, times your height, and then because it's a cone, it's going to be 1/3 of that. So it's kind of like a cylinder, but it's 1/3 of the measurement. So if we were to compare two cylinders, or a cylinder and a cone with similar dimensions, the cone would be 1/3 of the size. So my example that I wanted to run through here, actually I'm going to run through two quick ones. 7C, so it does have a cylinder with a cone on top. So again, it's just a matter of adding them together. And so we've got 1/3 is my cone times pi times radius squared times height. So put some information in there. The radius is 3. Make sure to square that, that's 9. Times my height, which is 6. Do all the calculations, I get 56.4. Then I also want to do the cylinder. So that's just pi times radius squared times height. So my pi, radius is still 3, squared, so 9, times my height of the cylinder is 5. Do that calculation and I have 141.4. So larger, of course, because it's not 1/3 of the measurement. Now I just need to add those two together, and I get 254.2 meters cubed for volume. So add this one and add this one. Okay, last I did want to just talk about this type of situation where you have a cone, you're given the radius, and you're given the volume, but you're not given the height, and you're asked to find the height. So we do know that with a cone, it's 1/3 times pi times radius squared times your height is equal to your volume. So if I put that information in, My radius was 12. And I don't know my height. But I do know my volume. So I can go ahead and calculate that. First, I'll do the 12 squared, which is 144 times pi. To make it easy on yourself, instead of like timesing this by 0.333, you can just do your multiplication, then divide by 3 as well, which you do get 150.8 times h still equals the volume. Then divide both sides by the 150.8. Sorry about not having room there. And in the end, your height is going to equal, when I calculated this, I got a couple of 9s after the decimal, so I may even just round that up to 27, make it a nice number. This was in millimeters, and because we're calculating height, that's a linear dimension, not a cubic dimension, and so we won't have a cubed on the top there. Okay, your job is to do practice your skills, practicing up. You can go ahead and work on the chapter 3 review, and once you're all done those, you can email me for your final assignment for this unit. Perfect, thank you, and we will see you on the next unit.